So this is problem 6 of tutorial 4. Here we have a cardboard without a lid, and it has a fixed volume. And given that volume, we need to minimize the amount of cardboard used. So in other words, we need to minimize the surface area of the cardboard of the box. Right. So here is what it looks like on the picture. Right. So here is so the cardboard is basically just a box. It consists of, well, generally a box has 6 faces, but here the top face is not there. So because uh, the question says the cardboard without a lid. So the picture looks like this. X, Y, and let's say Z. Now, the question is to minimize the amount of cardboard, so which means that it's the area of these 5 rectangles. The first one, the second one, and so on. Right. So the objective function is f of x, y, z equals the bottom part of the cardboard has area of xy plus there are this is the area yz, and the opposite side is also yz, so it's 2yz, and by the same logic plus 2xz. Right, so this is the objective function. Sorry, it's, let me write it better. So 2yz plus 2xz, 2xz. And what is the constraint? So the constraint is that the volume of the total volume of the box is x, y, z equals 32,000 cubic centimeters. Well, I guess for convenience, I will just call it V. All right, and the question is to find the minimum value of the objective function. So notice that we don't need to prove that it exists, so it's just kind of given to us. Let me just mention that in this case, the region of the 3D space given by the constraint is not bounded, and the maximum actually does not exist. So which is easy to see if you think about it. If you think of a very, very large and very thin cardboard, so imagine that x is very large, like much bigger than 1, y is very large, but z is very small, then just x times y is already a large number. But if z is small enough, then the volume is still small. So which means that the amount of cardboard used can be very large, right? So and it's not bounded from above, so that there is no maximum here. Okay, it is true that the minimum exists, but we are not even required to prove it, so we'll just take it for granted, and we will just solve the question. All right. So again, so let me write the objective function. Here is xy plus 2xz plus 2yz. The constraint g of x, y, z is x, y, z. Let me just write minus v is 0. So v is 32,000. It's just easier to write v. Okay, so now let me just solve it using the method of Lagrange multipliers. So the Lagrange function is xy plus 2xz plus 2yz minus lambda times xyz minus v. Now I will differentiate it with respect to x. The partial derivative with respect to x is y plus 2z minus lambda yz should be equal to 0. Partial derivative with respect to y is x plus 2z minus lambda xz is also 0. And partial derivative with respect to z is 2x plus 2y minus lambda xy is also 0. And the last equation is partial derivative with respect to lambda is 0, and the last equation is always just the constraint. So x, y, z is equal to v. Right? So these are the four equations with four unknowns that we have. And usually well, it's not always, but very often it is a good idea to solve for lambda and to exclude lambda from the system of equations, right? So let me do this. So I'm going to solve for lambda in the first equation. The first equation is moving this term to the right hand side and divided by yz. I will get y plus 2z divided by yz. From the second equation, lambda is x plus 2z divided by xz. And from the third equation, lambda is 2x plus 2y divided by xy. All right, and let us make use of the last equation, right? So, for example, so here we see yz, right? And we know that yz is basically v divided by x. So, which means that we can, in fact, replace yz with v divided by x in the first equation. So let me do this. Y plus 2z divided by v and times x. Well, but at the same time, in the second equation, I have xz, and xz is v divided by y, right? Again, from the third equation. So here, xz equals v divided by y. So this is, therefore, x plus 2z divided by v times y. And by the third logic, by the same logic, the third equation is 2x plus 2y over v times z. Because again, so xy equals v over z. Okay, not bad. So I don't need this anymore. But now I expressed a lambda in three different ways. So let me just combine the first two. So both of them are equal to lambda, which means that I can just equate them. So y plus 2z times x divided by v equals x plus 2z divided by v times y. Okay, so here I can cancel by v, right? now I can expand this. Expanding this, I get xy plus 2xz equals xy minus 2yz. Okay, so now I can cancel xy. All right, so nice. Now I can move this to the left hand side and cancel by 2 also. So xz minus, actually I don't even have, even have to do it. So xz, I don't even need to move this to the left hand side. So xz equals yz, and notice that I can cancel by z. So why can I do this? Z does not equal to 0 because I know that the product of x, y, and z equals v, which is not a 0, which is 32,000 cubic centimeters, right? But if z were equal to 0, then the product of x, y, and z would be equal to 0, not to 32,000. Right, so I can cancel by z because I know that it's not 0. All right, so x equals y. So I have just derived from the first two equations that x equals y. All right, nice. I guess I don't need all these calculations anymore. So I can just write that, okay, so x equals y. So now let me maybe look at these two equations. So again, because of the same logic, so I can, both of them are equal to lambda, so I can equate them together. So x plus 2z times, well, so notice that x equals y, so I can replace y with x equals x divided by v equals 2x plus 2x. Again, so y equals x, so I just replaced y with x times z divided by v. Now I can delete division by v. All right, so what do I have here? X squared plus 2xz equals 2xz plus 2xz. So again, 2xz cancels out. So the remaining part is just x squared equals 2xz. And I've already mentioned that z does not equal 0, but x is not 0 either, right? Because if x were equal to 0, then x times y times z would be 0 and not 32,000, right? So since x is not 0, I can cancel by x, since x is not 0. All right, but then this equation is just x equals to z. All right. I don't need this anymore. So now I have two, well, my first three equations, after I excluded lambda, my first three equations are reduced down to just two equations in on x, y, and z without lambda. So x equals y and x equals to z, right? So I can just write that x equals y equals to z, like this. And now I'm going to just substitute 2z instead of x and instead of y into this equation. So x is 2z times y is also 2z times z equals v, and now I will probably substitute the actual value, 32,000. All right, so now z cubed is 32,000 divided by 4 is 8,000, so z is 20, x equals 40, and y equals 40. And that's the answer. So maybe let me write the answer. So answer So the dimensions of the box of the minimum possible um, area are 40 by, sorry, 40 by 40 by 20 centimeters. 40 by 40 by 20 centimeters.